Artificial intelligence is shifting from a theoretical concept to an operational reality within the judicial system. Algorithms are being integrated into formal court processes, meaning digital architecture is now intersecting with legal adjudication. To manage this integration, policymakers have drafted the Guidelines for AI Oversight and Accountability in Courts. Specifically, Chapter 5 of this document serves as the foundational blueprint for oversight, audits, and incident management. Chapter 5 attempts to solve a massive engineering problem: how to mandate verifiable algorithmic accountability within a high-stakes legal environment, where errors can compromise judicial integrity. To achieve this, Sections 35 through 45 lay out a comprehensive set of technical rules. These regulations dictate the entire lifecycle of a court AI tool, from its initial technical assessment to daily operations, emergency fallbacks, and eventual audits. While these technical safety nets are rigorous on paper, the framework relies on a decentralized, court-by-court execution model. The safety of judicial AI will ultimately depend on whether this specific architectural system, designed to enforce these rules, is actually viable in practice. The first regulatory phase is a two-stage pre-deployment funnel. Before processing court data, AI tools face Section 35's Technical and Ethical Impact Assessment. Evaluators must verify the architecture, training data sources, and quantify risks of bias, error, and hallucination. The assessment concludes by mapping cybersecurity vulnerabilities and enforcing human-in-the-loop rules. Tools clearing this gate enter Section 36's quarantine zone, Stage 2 controlled environment testing, which explicitly severs the connection to primary court networks. The rules mandate a hard firewall for this testing environment. Sandboxed AI tools cannot interface with live operational networks, nor influence actual adjudicatory decisions. While rigorous, it diverges from external standards like DGPSI AI. The court framework fails to explicitly mandate a hard kill switch for critical risk scenarios. This pre-deployment funnel creates a theoretically airtight barrier, but its integrity assumes every evaluating committee has the technical capacity to measure abstract hallucination risks. Once an AI tool clears the pre-deployment funnel, the regulations shift from testing the system to policing its daily behavior. Sections 37 and 39 establish a continuous tracking infrastructure. Every court must maintain a detailed AI register, logging all approved systems, alongside an AI incident database recording any errors or malfunctions. Section 38 dictates annual technical audits, legal audits, and ethical audits for active tools. But Section 38 includes a restrictive caveat. These audits must be conducted strictly in-house. The rules forbid sharing source code or algorithms with any private third-party entity outside court premises. This side-by-side comparison shows how this requirement deviates from industry standards. On the left, Section 38 isolates the audit process internally. On the right, the DGPSI AI framework mandates independent third-party audits at both the developer and deployer levels. Prohibiting external audits ignores established safety benchmarks, placing the entire burden of verifying complex neural networks squarely on internal court staff. Despite automation, Section 40 ensures human authority is final. Supervising officers retain full discretion to modify or reject any AI-generated recommendation. Section 43 also introduces transparency obligations for legal representatives interacting with the court using AI. If a party uses AI to prepare evidence, they must explicitly disclose that assistance to the court using a formal declaration formatted as Annexure I. The framework enforces this with a punitive clause. If a submission contains fabricated AI content, the submitting party bears full responsibility. The AI's error cannot be a legal defense. In this phase, the court functions less like a purely adjudicatory body and more like a continuous technology monitoring hub. Zooming out to the policy's macro architecture reveals a network built on local autonomy. The framework maps the responsibility for implementation to 25 individual jurisdictions simultaneously. The guidelines push the operational oversight burden down to individual high court AI committees. Under Section 42, every court independently designs its own emergency fallback protocol, resulting in dozens of courts duplicating the exact same network engineering. Simultaneously, Section 41 forces these local committees to retroactively audit all legacy AI systems currently in use within a one-year deadline. The most resource-intensive mandate is Section 44, which requires a dedicated AI content verification authority to oversee all generative AI content. In practice, this means each high court would need to fund and staff its own digital forensic laboratory, capable of verifying algorithmic outputs on demand. This expectation is highly ambitious. Building cutting-edge AI verification labs at this scale likely falls outside the budget and scope of a localized court. Fragmenting these mandates leads to a predictable outcome, a duplication of engineering effort, and conflicting audit decisions between jurisdictions, and the risk that courts simply ignore directives they cannot realistically execute. By distributing enforcement across dozens of local jurisdictions, the regulation risks sabotaging the very safety standards it seeks to establish. There is a structural remedy that could prevent this framework from failing under the weight of its own requirements. Localized committees could be replaced by a single central expert team, governed collectively by the Chief Justices to provide a single source of technical authority. Centralization would resolve the logistical difficulty of technical assessments. Instead of 25 different standards, a central body could establish one national benchmark for the impact assessment process. A central hub would maintain a unified AI incident database and a single emergency fallback protocol, removing the need for redundant local engineering. Furthermore, only a well-funded national authority could effectively operationalize the advanced digital forensic labs required to verify generative AI content. If the decentralized structure persists, the regulatory framework faces a structural bottleneck that compromises its own implementation. Algorithmic accountability in the justice system requires a unified engineering solution to match the scale of the technology it seeks to control.